A very good evening to all of you. We are very pleased to have Professor Srijan Kumar, who will be giving today's talk. Anuj will be the host. And I'll just mention that this talk is being arranged with RNP, but through the Brij Disa Centre for Data Science and Artificial Intelligence. And there is a pretty large audience here, and Srijan, a lot of our audience comes from our business analytics program. So I'm sure this is going to be a very important talk for them, along with of the other participants as well. I'm sure there will be a lot of food for thought. Personally, I'm really looking forward to it. You are doing fantastic work, so we are really pleased to host you. And as I said, I would really like to extend my warm welcome to you, even for a physical visit whenever you can come to India. So with this, I will turn it over to Anuj to kindly host the seminar.
Thanks, Indu. And thanks, Srijan, once again for accepting our invite and taking out time to share the awesome research that you are doing. I myself follow your group's research as much as I can. So I was very happy when you accepted our invitation. So just a quick intro here. So Srijan is an assistant professor at the College of Computing at Georgia Tech. As far as his research is concerned, he develops data science, machine learning, and AI solutions for the pressing challenges pertaining to the safety, integrity, and well-being of users, platforms, and communities in the cyber domain. He has pioneered the development of user models and network science tools to enhance the well-being and safety of users. As I said, he's doing some really cool and awesome research here. His methods have been used in production at Flipkart. He has named to the Forbes 30 Under 30 class of 2022 and has received several awards, including the Facebook Faculty Award, Adobe Faculty Award. He was also ACM Doctoral Dissertation Award runner-up in 2018. He also has many other awards. His research has been the subject of a documentary and covered in popular press, including CNN, Wall Street Journal, Wired, and New York Magazine. He completed his postdoc at Stanford, received a PhD in computer science from University of Maryland, and bachelor's from IIT Kharagpur. Srijan, once again, thanks for doing this. And so we have approximately 1 hour with us, maybe 45 minutes we can have your talk, and in between, and then we can dedicate the rest to questions and answers. And in between, maybe folks can just raise their hands or put the questions in the chat window, and I can take it from there, or you can take it from there. So.
Awesome. Thank you very much for the kind invite, Anuj and the others. I'm super delighted to be able to be here virtually. I wish this was physically, but maybe at a later date. And I'm very happy to be able to share this work, and specifically for a reason that most of the talks that I give is in computer science conferences and computer science audience. So today I'm very happy to be able to share this important piece of work to you folks who are really experts in AI, data science, and machine learning, also its applications, and and bring it out to the world. So this is a multi-stakeholder problem about cyber safety, online misinformation, hate speech, and so on. And it really needs all hands on board. So I'm very happy to be here, and I'll get started. But before I do, feel free to stop me at any point in time. You can just unmute yourself if that's allowed, and ask questions. I love it when it's interactive. So advances in AI for cyber safety. And how many of you, just quick show of hands, or you can use the emoji or whatever. How many of you have social media accounts? Facebook, Twitter, Snapchat, whatever. Okay. I see a lot of raised hands. I'm assuming every one of us, right? It has become such a crucial part of our life, where people actually spend more than 20% of their waking hours online. And that's a lot. right? 20% is a huge number. And surveys have shown that people get more news and information from social media than from traditional news organizations. Uh, and every country has different social media platforms that are popular. In India, WhatsApp is one of the most popular quote unquote social media platforms where people are connected to their friends and families and their business contacts, and they get whatever's trending and whatever's important through these platforms. So what this shows is that online content and users really shape everyone's opinions. And the challenge is that not everyone has good intentions. There's a lot of misbehavior out there, which is quite harmful. So to give an example, 40% of people have been harassed by online trolls. So if you think about it, uh, among the however many 35 people who are there in the call, 40% of people have been harassed, and even more number of people have seen someone else being harassed rather than being harassed themselves. Many platforms have been adversely affected, and they've turned off their online comments because of this cyberbullying. And coming to fake news and misinformation, which we know is prevalent and quite damaging. In the context of elections, 19% of voters in the previous US election, actually 2016 US election, said that fake news in some way or the other influenced their vote. That is huge, considering that who wins the elections primarily is determined by by the middle portion who are not in the extremes. If any party or any candidate can influence them, or if external forces can influence voting decisions made by people in the middle, then that can adversely and drastically change who comes to power. There's also a lot of hate speech and other type of online misbehavior that's going on, and I'll talk about some of them in this work. So broadly, misbehavior can be categorized as malicious users who are doing this bad activities, and false information, harmful and dangerous content that is pervasive in the network. So it's not just the people who are spreading misinformation and bad content. There's also a technological angle to it. And believe it or not, most of the things that you see online, whether it be on e-commerce platforms like Amazon or Flipkart, or on social media platforms, or whichever platform you go to, technology has a huge role to play in terms of what you are shown. And people have raised questions, and some people have shown that recommender systems, which are one of the most pervasive technological factors behind content being recommended, being shown to people, and promoting and creating trending topics as a whole, recommender systems themselves can be either manipulated or can be bad in terms of showing bad content to folks. So for example, Instagram, and there was a news article in NPR where it says that Instagram suggested post to users it's served of COVID-19 misinformation. TechCrunch reported that YouTube's recommender system is bad, and there have been so many different articles about YouTube's recommender system pushing people to fringe content, pushing people to content that they should not really be seeing. Even children are being recommended content about very dangerous, harmful topics. Facebook's recommender system has been blamed to spread hate, and Amazon's recommender system is blamed for recommending anti-vaccine books. So essentially, it's both a people problem and a technology problem, and we have to consider and we have to treat it as that. So the main research question that I aim to answer is how to characterize, detect, and mitigate both the social and the technological factors that affect the safety, integrity, and well-being of everything online. And this is an important problem because so many of us, especially the younger generation, are impacted by it. I was just talking to one of my younger cousins the other day. She's 16 or 17 years old. And I was asking her, what's the most popular social media platform you use? And she said it's TikTok, Instagram, and Snapchat. So it's, and if you talk to older people, or at least you talk to my family members, they'll say WhatsApp is the most important, most prevalent social media or social media platform that they use. And some other generation will say it's Facebook. So it's a problem that not one platform can solve together, can solve alone. And really you need solutions that go beyond a single platform and look at multi-platform solutions to do this. And this is a very complex problem, and primarily because it's a moving target. Let's consider just misinformation. Misinformation is, with every changing topic, every week or every month, the type of misinformation changes. And the strategies that bad actors use to spread misinformation changes. Today, it's about COVID vaccine misinformation. A few months ago, it was about the origins of COVID-19. Before that, it would be elections, and soon thereafter, it will be elections again. So there's any societally relevant problem, any big problem that you take, there's going to be misinformation, and it's a very big and complex problem that requires inputs from multiple stakeholders, taking statisticians, computer scientists, policymakers, epidemiologists who really help us study how misinformation spreads, communication scientists, psychologists, and people who really understand how to make an impact on the world by taking all of these things together and putting it out in the world. So startups and people who are at positions of power, both at companies and at within the government, who can make strong decisions. So given that it's such an important problem, we need people to recognize how we need it to be recognized at all different levels, and we need people with different skill sets to solve this problem. So today's my attempt at showing three different ways in which we can try to help solve this problem using AI, machine learning, and data science. I'll briefly pause here before I jump into the technical content, and happy to take any questions. I see that there's one raised hand. I don't know if it was from my earlier question or not, but Anshuman, please go ahead.
Yeah, hi, hi, Srijan. I just had one basic question because the research topic you have concerns itself with the safety of users, right? But at the same time, I think when you spoke in your introduction, you told like misinformation and other bullying and other activities. So do you categorize misinformation also as a part of safety of the user, or is like you're dealing with that separately? So I just wanted to understand that.
Certainly, right? Like misinformation adversely affects the safety of users, not necessarily or not specifically of folks online, but in the real world. COVID vaccine, like that's a current, very topical and very timely example of how online misinformation about COVID vaccines has prolonged the pandemic and how it has led to so many preventable deaths. And it's still doing that. And we don't even know when the pandemic is going to end. So it's not just about the mental health safety issues, but really people's lives are at stake because misinformation is there. Let me give you another example. at least in US, whenever there are elections, there's misinformation. And people really take that seriously. And there have been riots. There have been, in last year, January 6th, the US Capitol was attacked, and so on and so forth. So there are real implications of misinformation that adversely affects people. And my goal is not to just create an online safe environment. It's to create my big vision is to have a better, is to create a better world, help create a better world. And this online misinformation, online hate speech, which we'll look at as well briefly, bullying, false reviews on e-commerce platforms where people lose money. All of these are different examples of the bad things that are there on the internet, that not just safety, but safety, integrity, well-being of folks online and in the real world.
Thank you.
Okay, let me start with the first main thrust of my work today, which I'll be showing, in which I'll be discussing some of the advanced detection systems that we have created with natural language processing and graph and network analytics. And what we aim to do is to create early warning or early detection systems for bad content. And these can be detecting people who are being malicious and spreading bad content or harassing others or spreading fake reviews on e-commerce platforms, for example, or misinformation or content. So we want to create early warning system for different type of bad content as well. And to do that, we really use social network structure. So the way people are connected with one another, the way in which content is spreading, and so on. We look at the content itself, because what is being said is super important. And we look at how it is spreading in terms of, let's say, the time it takes for content to spread, because people have shown that certain type of content is more viral and spreads faster compared to certain other type of content. And this broad set of tools and techniques that we develop have been applied, and we continue to apply it for different types of detection and prediction tasks, including e-commerce fraud, detecting deception using multiple accounts, so coordinated bad activity, fake news and misinformation, and hate speech content. And there are more. Let me give you an example of COVID-19 misinformation work that we have done because of how timely it is. So what we did was we created back in March 2020, when we started this work. That was really when when COVID-19 was out in the world and people were starting to know about it. There were two broad categories of misinformation of COVID-19 that was spreading. One was that 5G technology causes COVID-19, and this actually led to people pulling down telecommunication 5G towers in UK. And there were fake cures that people were taking to cure themselves or immunize themselves of COVID-19. And this is one example where someone's suggesting to take garlic because of whatever reason. And in fact, I've personally received various different fake cures of COVID-19 on my family WhatsApp groups. It's just so prevalent. So back in the day, I got, I believe it was gargling and taking and putting, I think it was some herbs, maybe tulsi patta in the front pocket of your shirt, and then it will prevent COVID-19. All of these are fake cures, doesn't really work, unfortunately. So we set out to look at how COVID-19 misinformation was prevalent in using web and social media data. And we created a crawlers that looked back in time and collected data from January all the way through May 2020 on Twitter. And we used a keyword-based collection technique where we specified a set of keywords related to 5G and different types of fake cures and COVID-19 to collect whichever tweets during this time frame had these certain keywords, and that gave us about 8 million tweets. Now, not all of these 8 million tweets are misinformation, and it's not possible for us to look at each one of them to say whether it's misinformation or not. So what we did was we used machine learning and natural language processing techniques to help identify really which one of these 8 million tweets is misinformation. When we started doing this in March, there were no data sets, no ground, quote unquote, what you call ground truth labels of misinformation and counter misinformation. So we are interested not just at looking at how misinformation is spreading, but also how counter misinformation or how true information that is saying that no, this is misinformation, how that is spreading. And that was important because it's not that misinformation is spreading on its own or in isolation, but there are also people like fact checkers and concerned citizens who are spreading counter misinformation in an effort to combat the spread of misinformation. So we wanted to see how both of this information affected one another and how both of these type of information were being spread. But at that time, there were no data sets that we could use. So we created one ourselves. So two of my students, they labeled 4,800 tweets manually into these three categories: misinformation, counter misinformation, and neither or irrelevant. And they had a high inter-rater agreement, essentially saying that both of them agreed 80% of the times or more with the labels that both of them labeled. So based on this, we got one of the largest data sets that has the ground truth of both misinformation and counter misinformation. And to complement, we also collected data sets of about 7,000 fact checks done by professional fact checkers who were part of the ISCN network. So there are a lot of professional fact checkers who are helping identify misinformation and debunk misinformation. So we crawled this data set, which has around 7,000 fact checks. Now, as you can see, we have about 8 million tweets, and we know the ground truth labels, so we know what's misinformation and what's counter misinformation for about 4,800 tweets only. So we need to give a label for the remaining tweets, which is a daunting task if done manually. So we don't do it manually, but instead we create text-based classifiers. So we look at the text of the tweet and we create different types of classifiers to see how well they can help identify this whether content is misinformation or not. And in our attempt, we created 3 different types of classifiers: hashtag-based, BERT embedding-based, and an ensemble model that has both. So hashtag-based classifiers are essentially creating a vector for each tweet text. And this vector is a one-hot vector, which means there's a 1 with in the axis if a certain hashtag is present, and a 0 if the hashtag is not present. So there were a lot of hashtags. I believe more than 2,000 hashtags were present. So we convert each tweet in this first type of classifier. Where's my cursor? Yes. In this first type of classifier, we create a vector which is very, very long, and it has mostly zeros and a few ones corresponding to the hashtags that are present in the tweet. Then we also created a BERT embedding based classifier. So BERT is a very popular, it's the most popular technique to convert any piece of text into a compressed vector representation, where the vector has both the semantic and the syntactical content represented encoded into the vector itself. So if you are interested to learn more about BERT, there are a lot of different resources that you can use. but essentially you can think of it as a model or a black box where you put in the input and it gives you a vector of certain dimension, let's say 50 dimensions, that can then be used for downstream processing. And then we also created an ensemble model where we use the vectors, where we use the information from the hashtags and the BERT embeddings and combine both of them together to create a classifier. And we use different types of classifier, but this is results from one of them. I believe this is logistic regression classifier, and for each of these categories, misinformation tweet detection, counter misinformation tweet detection, and irrelevant tweet detection, we look at precision, recall, and F1 score. These are the three metrics that are most popular when there's an imbalanced data set. And what we see is that hashtag-based methods have very, very low precision. It's around 0.4 in detecting misinformation, while embedding-based, BERT embedding-based misinformation detection model, which was the second one over here, that has around 0.763. It has decent recall and overall a very high, a high F1 score as well. Hashtag plus embedding based models, which essentially means you take the embedding model and also add hashtags to it, they slightly underperform because of the confusion and the long vectors that have been introduced because of the hashtag. So embedding based models performs the best in identifying misinformation tweets. It's not perfect. Higher scores are better. Maximum possible score is 1, but in this case, we get 0.775. So it's not perfect, but it's still manageable. Similarly, we also created classifiers for counter misinformation tweet detection, in which also embedding-based models perform the best, and also irrelevant tweet detection, which has similar performance. So essentially, it turns out that we shouldn't use hashtags to detect misinformation or counter misinformation. We just use the BERT-based embedding models, and they perform reasonably well. And what we can do is, if you are interested, you can also create other types of classifiers using this. So the way more advanced NLP techniques that have been created that use more recent models, more recent large language models that can be used to help create better embeddings and potentially improve the performance of the classifier. Our goal wasn't to create the best possible classifier, but to use these classifiers to help understand the ecosystem of misinformation and counter misinformation. So what we did then is use the BERT embedding classifiers and ran it on all the 8 million tweets. So essentially, every tweet that we had not labeled manually, we ran it on all of them. And this helped us to create the largest data set that has misinformation and counter misinformation, and that's not just based on URLs. The previous work has looked at whether a certain URL from certain domains are present in a misinformation in a tweet or not to determine whether it's misinformation or counter misinformation. Ours was the first work to look at how text embedding based models can be used to create non-URL based misinformation and counter misinformation tweets. And then we created these classifiers for both 5G and fake cures of COVID-19, and we ran it on all the tweets. And what we found was that there were in total around 33,000 misinformation tweets, 441 tweets that have professional fact-checking URLs, around also 33,000 counter misinformation tweets made by ordinary users, and several irrelevant tweets as well. So overall, this gave us a reasonably sized data set to study how misinformation and counter misinformation coexist in the internet space, and we can then see how they influence each other and the impact that they have on each other. Okay. I'll briefly pause here and take any questions that you may have.
Professor,
Yeah.
Lalit here. I know this aspect of detecting fake news or understanding the credibility of what is being tweeted has been there for some time. I'm guessing it will always be there because the way people write is always going to be very complex, right?
Absolutely.
How do you see this in the next 2-3 years evolving, considering that training models is going to be painful because someone needs to sit and annotate the data? Did you explore anything on reinforcement learning or any of the advanced models where training is minimal, or probably there is no training, but they just keep exploring and understanding whether is there really a credibility in, or a fake news that's being put in there?
Great question. Thank you. So there are advanced techniques, or more advanced than BERT, that one can use. And these are really models that can be trained using very small amount of training data. So essentially you take large language models such as T5 or MT5 and so on, and these are already pre-trained on large corpuses, and these are publicly available. Companies have released them, and what you can do is you can really label a very small amount of ground truth data, let's say a few hundred data points, and you can fine tune these models. You can fine tune these large language models on this small amount of data and ensure that, and then using that, you can create a model that is specific to your task. So these generalized models that are there, large language models that have been created, these are like general purpose models that have a basic understanding of language. These are not typically trained on social media data and do not encapsulate all the different ways in which people are writing. But using the small amount of training data that you can label, you can really fine tune your large language model. You can really fine tune your model to be able to identify, to make it specific to your use case. So don't really need to use like thousands and thousands of data points, and that makes it more feasible we could have done this for this work as well. We just didn't do it, but we are doing it for one of the papers that we are submitting next week or 2 weeks from now. But yeah, this standard technique of taking language models and then fine tuning it is quite effective and doesn't require a lot of effort. That is one way. Specific to misinformation, we can create models that not just look at text, but also look at who is sharing the content. What are the properties of this immediate social network of the folks who are sharing the content? How is the information spreading? And so on. We can use all of those signals as well to create early warning systems and early detection systems. So since we have that information in this particular case, we can do that, and that can help us create forecast even misinformation that may using very small amounts of data. We recently got a National Science Foundation grant here in the US, where we are trying to forecast which communities may be prone to misinformation, and which communities may, given a specific topic of misinformation, which communities may be targeted or maybe more vulnerable to that specific type of misinformation. We can even do that so that we are one step ahead. Even before misinformation spreads, you can essentially put certain communities on quote unquote high alert and monitor those communities more specifically. So depending on which type of problem you're looking at, you can create such solutions. But broadly, looking at how people write on social media platforms or in any platform for that matter, in general, we can use fine tuning of large language models to help solve that problem.
Okay. Thank you.
Thank you. Mukul, you have your hand raised.
Yes, hi, Srijan. So I have a little query about the biasness while we are labeling the text. So maybe garlic work for me, and I will label that tweet as yes, that's a fact. Garlic help in in certain cases or something. And there could be tweets which are not like you showed in your previous. It says it enhances or something, the word combat. It doesn't say that it cures, it combats. So maybe as a person, if I go into literal meaning, combat is something which give me any strength, right? So such dicey sentences, how are we dealing with such dicey sentences and the biases of the labelers?
Okay, thank you. So that's an important question, and we are not the arbiters of truth, right? Like, we are just researchers. We don't say what is true and what is false. We rely on, let me see if you can see this or not, this IFCN data set. So professional fact checkers spend hours and hours looking at one piece of content and really digging up evidence, scientific or otherwise, to really give a label to whether something is true or false. So they have said that, and they are backed by articles from various different health organizations around the world, including WHO, that, hey, these are topics of misinformation, that 5G is known that it does not cause COVID-19. Fake cures do not cause COVID-19. That there are some fake cures that are out there, including garlic and taking lemon and honey in a cup of warm water. All of these are fake cures that are circulating. They do not work. It's not harmful, but it does not work. There's also harmful misinformation, which we did not look at in this work, but there's people who drank bleach because some politician, not going to name whom, but some politician said that in the US said that, hey, if you drink bleach, you don't get COVID, or you can cure COVID. A lot of people did that and went to the emergency room. There's fake cures of, I believe, what's that? Ivermectin, and there's one other, right, that's going on right now. So there are a lot of different types of fake information that's there, but I don't decide, and my students don't decide what's that. The professional fact checkers do, and we take their word for it because that's their job, and we use their content to say whether something's misinformation or not. So that's how we do it. We don't decide.
Sure. And another one, could LDA help us to define the topic? Rather, we later we can verify it with the labels, but in the initial set of EDA, couldn't we have used LDA?
You can use LDA. It can give you high-level topics, but it won't really help you identify what's misinformation, because I can have a tweet that says garlic cures COVID-19, and I can have another tweet that says garlic doesn't cure COVID-19, and both of them will be part of the same topic because it has garlic and COVID-19, right?
Yes.
But the meaning is entirely different.
Okay.
So LDA is good to visualize like what's high level, like what's at a high level, but if you really dig into something, it doesn't really help that much.
Okay, sure. Thank you.
I have 2 raised hands.
Yeah, so maybe I'll go first, if that's fine with Ashraf. Srijan, I have a question about BERT. So is there any specific reason that you went ahead with BERT and did not explore some of the other more robust versions of BERT and all? Just wanted to understand, based on what did you choose BERT in the context of analyzing the tweets? Because we are doing a similar sort of a study in a different context. And some of the other models are outperforming BERT. So in case you have some ideas to share that what might work better in what context, I think that would be helpful.
Absolutely. No, I think we went with BERT because it is the most popular model that's embedding based, and we could have used more advanced models. We did not, because our objective was not to create the best possible model. In hindsight, we could have done that. But there are more advanced models. Certainly, there's Albert and Roberta. Roberta seems to outperform BERT in all the cases that we have seen. I'm sure it would outperform in this data set as well. We did not do that, and typically, I would say that if we were redoing the study now, or if someone's doing a new study on whichever topic, use Roberta or use more advanced models like T5 or MT5. And if you're doing multilingual, MT5. If you're doing monolingual, then you can do T5, right? So these are all the different types of models that are there. And really, we have seen, it also depends on the computational power that you have. Because MT5 and T5, these are models that are way larger, which means you need larger GPUs to train, to fine tune your model and to run your model on them as well. So yeah, I mean, we went to the simpler approach because no specific reason, but I guess you can use Roberta or some of these more advanced models.
Thanks a lot. Thank you very much.
Ashraf?
Hi. Okay, part of my answer I already get from Professor Ankul's question. So one small query, I have some basic query. It's regarding mainly the use of any classifier. Suppose when we use any classifier, is there any way, standardized way to decide, to when we can say what is the minimum size of minimum training size data we should have? Like in your case, you have used approximately 5K. You read 5K, 5,000 around tweets. Why not less than that, or why not more than that? So is there any standardized way that I can say that this is at least we have enough training set data?
Good question. Okay, that's a tough one. I don't know if there's a back of the envelope calculation that you can do to identify what's the amount of training data that you should use. I guess it comes more from domain knowledge to know that, hey, this type of models need these many data points. For BERT type models, typically it requires like 2,000, 3,000 type of data points. We added more just so that, to be on the safer side.
Okay.
I would say, yeah, you need some domain knowledge to see how many data points you should use. Larger models, of course, require more data points. So that's the trade-off that you have.
So when you're saying larger data model, so this BERT is not a larger data model?
There are larger ones as well. As I was just replying to Professor Sinha, right? You have Roberta and T5 and MT5. They're much larger than BERT. When I say larger, it means they have more neural network parameters. BERT is a neural network model, right? So there are more neural network parameters that need to be trained. That means you need more training data points to be able to get to the same performance as the original, as a smaller model. But they have a potential to outperform the model as well. And that's why people actually do use these larger models. So yeah, that's the trade-off that you have.
Okay. So in your case, I suppose, have you checked whether, suppose you have the radar from 5,000 tweets. Suppose, if you would use in your training set only half of it, what is the result of it?
We haven't done that, but we have released the data. So you can actually do it. You can take the label, you can retrain the model if you like, and you can see what the performance is with respect to the number of training data points, right? So I should have okay, the link should be on my website. So if you go there, you can download the data and you can experiment with it.
Thank you.
Great questions. Are there more that I can answer at this point? Okay, if not, let me go ahead. So as I was just saying, we have we ran the BERT model on all the tweet data. And then the reason we separated counter misinformation into professional fact-checking tweets and ordinary user, or what we call citizen-based counter misinformation tweets, was to show this difference, that professional fact-checkers, there are only 441 tweets in the entire data that use professional, that have URLs to professional fact-checkers, while 33,000 counter misinformation tweets do not. So what it shows is that professional fact-checkers have a low reach. Even though they're doing so much work, like really, I've talked to professional fact checkers in my research, and they're spending hours and hours to dig so deep and look at so many articles from different sources to label one piece of content. But their work is not really being used as much by ordinary users or in the real world to counter misinformation as we would want. So this is a big problem, and it's important to find solutions to ensure that correct information has broader reach. So our potential solution, given the statistics that ordinary users are spreading more counter misinformation than professional fact checkers, our one potential solution is to develop a community-based counter misinformation approach, where we can empower common users with correct information so that they can combat and counter misinformation when they see it. And we see that 96% of the countering messages are in fact from ordinary users, given the previous statistics. But we also see, let me move this. We also see that ordinary users, when they're countering, they are quite inefficient. What I would quite nice words I would put, that they're inefficient, they're quite rude, they don't provide evidence, and they have no empathy. So they would write tweets. This is still counter misinformation, but they would write, people who think 5G causes COVID-19 are stupid. They would make such tweets, and this is the bulk. In fact, 2/3 of tweets are like this, that are rude. They don't provide any evidence. And we want to empower users. We want to create tools, and we are working on such tools to enable users to counter misinformation in a nicer way, in the sense, and this is one real example as well from the same study, where you have the fact, and then you have a link that where people can go and study more. That's not rude. I wouldn't call it polite because it's factual, but it's at least not rude, right? So we want to get people to go from here to here, and we want to empower and we want to encourage users to counter misinformation when they see it. And that's the idea behind Twitter's Birdwatch system. So Twitter has a new system that they launched last summer, I believe, or slightly before that, where people can go and label misinformation when they see it on the Birdwatch platform. And this work that I'm just talking about, this is one of the works that influenced their system to show the feasibility that yes, people can help counter misinformation. So that's one of the works that helped us show the power that ordinary users can have when combating such a big problem like counter misinformation. Let me take like 5 minutes, and then I can take more questions to go into another work that we have done, where we used not the content, or not just the content, but also the social network. And this is to one of the questions that was asked earlier, where I referred to this, where we can use the dynamics in social networks to understand how information is flowing, how people are interacting with certain content, and use that to really quantify or classify and predict different types of content and different types of users. And this is one of the works from KDD, ACM SIG KDD a couple of years ago. The previous work that I was talking about, this is from IIIMA, all of this COVID-19 misinformation work. This is from last year's, or 2 years ago, IIIMA Big Data. And this work is from ACM SIG KDD 2019. And the goal is to understand the temporal dynamics in networks to be able to make predictions and classifications. So here we have an input, which is a temporal interaction network. So essentially a network created by looking at who interacts with whom. So let's say you have a social network, you see who is liking a comment, who is writing a comment, or who is making a post, and then who is interacting with those posts. And Facebook does that, by the way. I'll go into that. But you can create a network out of it where you have people on one side and you have content on the other side. And edges are from people to content, showing the interactions that are happening. And we can create embeddings representing the instantaneous state of the person and the content as the output. And to do that, we use a deep learning model. I'll explain that in a minute. But what we want, okay, when a user interacts with a post, let's say about a movie, we create an embedding representing the user and the movie in a shared embedding space. So embeddings are essentially vector representations of entities. And in this case, the entities are users and items. And this item is specifically a movie. And as time goes by, more user nodes, more item nodes are created and corresponding embeddings. And as users have more interactions, their embeddings are updated, right? So essentially, using this, you can see that where the embedding of the entity or the user was and how that has evolved over time. And you can use these embedding trajectories or dynamic embedding trajectories to see or to quantify or to classify whether content is good or bad, whether users are malicious or not. So the input is this real temporal interaction network that one can create looking at interactions on social networks and social media. Or in an e-commerce platform, you can have these temporal interaction networks, by the way, are quite general. Let's say you are a bank, then both sides can be people, or this side can be people and this side can be different merchants, and edges can represent who is making a purchase where. You can also represent an e-commerce platform using a temporal interaction network where you have users and you have products, and edges can represent different interactions such as adding to cart, removing to cart, viewing a product, and so on and so forth. And these numbers on edges, if you're wondering, these are timestamps. So this interaction happens first, this is the second interaction, and so on and so forth. So these temporal interaction networks are quite general way and a very powerful way to represent complex dynamically evolving information, which we can feed into what we call what my model is called, which is JODI, which is a mutually recursive recurrent neural network framework, which can enable us to create this unified representation in an n-dimensional embedding space to represent the different entities in a shared space. And using these embedding trajectories or sequence of embeddings, we can make predictions. So these embeddings, you are all aware of these, not embeddings, but trajectories. So the way Google Maps predicts where you are and where you have been and uses that to predict how much time it will take you to get to a position, they use these trajectories and they use Kalman filters on top of that. Or a very basic, I'm simplifying it a lot, but we do something similar. We take trajectories in these vectorized embedding spaces and we make predictions on these embeddings using Kalman filters as well, which is the JODI model. Not going into the details, but happy to discuss it offline if someone's interested.
Sorry, I just have a quick question over here.
Yes, please.
This is quite interesting. Can you just go to the previous slide?
Yeah.
So what I understand is what you're talking about is in the high dimensional space, you have the embedding. And since on the left-hand side, you have the temporal interaction network, so you're getting different vectors at different point in time in the space, right?
Absolutely.
And based on that, you are able to make some forecasts and stuff like that, where the next vector is going to be. And that essentially tells you that how the network is going to evolve, if I got it correctly.
Yes,
so,
yes. How the network is going to evolve and how individual nodes are have.
So now the next thing would be to do a mapping from the vector space back to the network as well.
We don't really. Okay, good question.
Yeah. So you're going from the network. You're going from the network to the vector space, and now you know that how the vector is moving and everything. But now let's say there is a prediction that the next vector is going to be this. Now, if you want to know how the network has changed, you need to do a reverse mapping as well. Am I right?
Right. Yeah. Great. Okay. So that's a great question, because that helps me answer two things at once from this plot. What you are talking about, Professor Sinha, that is that if you forecast these trajectories and say that, hey, user one is going to interact with item 10, then essentially that's a recommendation system, because you are predicting that, hey, if you recommend item 10 to user one, that is very likely to happen. So that's exactly what we do, in fact, as well. We do user classification, entity classification, and recommendation system using this type of model. And it helps us overcome shortcomings of existing models quite a bit as well. So yes, we do that, and we actually map it back to the original network to see how many times our predictions that certain users interact with certain items, how many times that is correct. And we show that we are correct more often than existing models. And in fact, that's true. And the other task that we do is to take these trajectories and say, hey, whether this is a normal trajectory or an abnormal or an anomalous trajectory. And then we can use these trajectories to classify. Now, you may be wondering how we can make predictions that, hey, this user is going to interact with, or this user is going to interact with this item, or essentially the way you can map back from the embedding space to the network space, which was Professor Sinha's question. And to do that, we train essentially a simple linear layer, layer on top of the embeddings. So the input will be this user embedding and this item embedding, and it will try to make a binary prediction of whether these items, whether this pair will interact or not. If the answer is yes, or you can, then essentially we are predicting that a certain user will interact with a certain item. So that's how we go from the output space back to the input space, and it works quite well. We also took this model and ran it on two data sets that we created from Reddit and Wikipedia, which has ground truth of malicious users. So Reddit has in our data set 10,000 users, out of which around 366 were blocked, and Wikipedia 217 were blocked. And we were able to show that compared to various different baselines, our model is able to identify who will be blocked and who will not be blocked, at least 12% better than baseline. So we're able to identify malicious users. We also did the recommendation task, where we were able to predict more accurately than baselines which user item pair will interact. So essentially a recommendation system. And there we outperform baselines by 20%. So this model is general because it really uses the power of the network, and it can be augmented with text content as well. So I'll pause, I'll finish here actually, and just say that some of the work that we have done has for fake reviews. I didn't talk about those, but fake review detection system has been deployed at Flipkart to identify fake reviews in an ensemble. It's not the only system that they're using because it's a big company, but they're using a set of systems. They're also working with Wikipedia right now to identify bad actors who, when they are identified and blocked from the platform, they will create a new account to evade the ban and continue their malicious activities. So how can we detect them? So the paper was just accepted at ACM web conference. It will be presented in April, and it's on Wikipedia. So they are working with Wikipedia to do that. And the counter misinformation work that I talked to you about, that has influenced Twitter's birdwatch system. So let me finish here and thank all of you for your very interesting questions. And I'm happy to take more questions if there's time. I'd planned originally to also talk about these two topics, but I'll share the slides, and if you are interested, you can go over it yourself. And happy to answer questions about that as well. So with that, let me conclude and thank again for inviting me, and it was really interesting and really thoughtful questions that that I was able to answer.
Any questions?
Thanks, Professor. So did you compare with crowdsourcing model like Web of Trust that can be sitting as a plugin in the browser, and you're always taking the feedback from the user? Because at the end, model can only do what the data it is trained on, what it is observing. The real user would know it probably better. So is there a feedback mechanism that you're involving in? Second, well, there's some work that Professor PK.
I know PK. I work with PK, yeah.
No, you did. Okay. So you know his feed to cred work, and Professor, I think Niloy Ganguly from IIT Kharagpur also worked on something on the Twitter. Did you compare anything, what their approach is versus your approach?
Great questions. Thank you. The first question was for those in the audience, to remind them, the first question was, can the users give feedback? Is there a tool in which users can provide feedback hey, this is I'm assuming your question was about misinformation. So is this misinformation, or hey, I think there's a misinformation, so on. And as far as I know, there's no tool like that. I'm in fact writing a NSF proposal. It's in the works right now. The goal is to help create such tool, which will not only enable people to report misinformation when they see it, but also help them write better counter misinformation posts like this. Right? So that's a work in progress. I'm not aware of any tool that is able to do that. And I believe that it will really help solve, or it will take us closer to solving the misinformation or hate speech problem that's there. Whatever I talked about in in misinformation, we have also done another work which was published at ASONAM last year. We did a similar work, but looking at anti-Asian hate speech during COVID-19 as well. So same thing, right? Like same type of text-based models being used to do hate speech and counter hate speech detection. And similar models can be developed in the sense, similar tools can be developed to help people write counter misinformation speech better and detect hate speech when people see it. So such tools do not exist, and we would like to create them. The second question was, did you compare with some of the other tools that have been created by Professor PK or Professor NG at IIT Kharagpur? By the way, I did my bachelor's at IIT Kharagpur, so I know NG quite well.
Sure.
NG, AM, and some of the other folks who are there. Yeah, great folks, great research. So we typically compare with whatever's the state of the art at the time. So we compared, in this case, for example, with all of these models that were state of the art, right? So we do a thorough search and we identify whatever's the latest model. Research is so fast moving that 3 months later, my model would not be state of the art as well. So we take whatever's the state of the art and we compare it with this. Thank you. I see a couple of raised hands. I don't know if Ashraf.
Yeah, Srijan, this is Indranil here.
Yes,
First of all, thank you for your very insightful presentation. I think you presented in a way that all of us could understand it very well, what was the work that was going on. Two questions, one from each of the research that you presented. The first one for the 5G versus the COVID cure, fake information research. I was wondering that did you get into what was the content inside it that triggered the misinformation? For example, I mean, you are finding out that these are misinformation in some way, but are there prevalence of certain words or certain specific content within it that would be helpful for people to know that if I see these words or these hashtags, then this actually means misinformation. So that's the first question, whether you do get into the content part in order to discover some rules or something like that for determining misinformation. The second question is, in the deep learning framework for the, where you're seeing interactions between people, do you also check people's reactions when they interact with these components? For example, whether they write something happily or angrily, or whether they are pushing that content to multiple other people on the network. Do you check the user actions and the type of user actions in it? So these are the two questions that I have.
Yeah, thank you. Both are very thoughtful, very nice questions. So the first question was, do we look at the content while deciding whether something's misinformation or not? And can we create some rules out of those so that people can be helped? So yes, we do look at the content. So we look at the hashtags that are present, and hashtag is a very platform specific thing, but you can do the same thing with WhatsApp messages and look at what contents, what keywords are there. So hashtags are essentially keywords, more or less. BERT embeddings are more advanced versions. So if you're familiar with bag of word models and so on, BERT embeddings are way better than them, way more advanced and deep learning based as well. So it has the power of deep learning behind it. And BERT embeddings are one way of incorporating the content, the semantics of the content and the content itself. So yes, since we are using BERT embeddings, we are using the content as a whole, not just the words and or which words are present and which are not, but the entire way in which the entire content is written. So yes, we are using those.
But my question is, although I understand that you're using the content, but that content remains latent to the researcher, because the researcher is not really concerned about the content. They're more concerned about your prediction accuracy, precision recall, etc., rather than whether a specific content is leading to more misinformation than others. Right? That's of course the content is the key here. Of course, without the content, you would not get the misinformation. But specific type of words or topics or hashtags, whether they lead to more misinformation. And I would tend to think that the kind of words or topics for 5G would be very different from the type that you would see for COVID cure. So it's very much content or context specific, I would say.
Absolutely. I think if you draw a word cloud, which of tweets that are misinformation and tweets that are counter misinformation, and contrast the word cloud, you would be able to get that. You can even do something similar. I don't have the plot here right now. It's in my other set of slides, where you can essentially draw a more or less a histogram of the frequency of which certain words are appearing or certain hashtags are appearing. And you can kind of see what the prevalence of or how prone a certain hashtag is to misinformation. People have done that. It has its merits and shortcomings as well. We did something similar, but we looked at URLs. So which URLs are more prevalent or more are more prevalent on misinformation and encounter misinformation. Let me see if I can find that plot very quickly. This is my slide, and this should be the one that should have it. All right. So this is, I did what you are saying, but with URLs. And this is the frequency of URLs, different domains present on misinformation topics, and different URLs or domains present in counter misinformation tweets. And quite interesting if you see, because YouTube is the most popular URL in both the in both categories. So people are using YouTube to spread misinformation and to counter misinformation. And you can see different types of websites. And in fact, third party or unregulated websites like YouTube and Instagram, these are more, I don't know what stateofthenation.co is, but a lot of different websites are appearing to spread misinformation. and yellow are known low credibility websites, and a lot of them are, of course, present to spread misinformation, while a lot of more reputed, or what ISCN or other platforms believe to be high credibility, they are spreading counter misinformation. So we have done what you're saying, but with URLs, because this gives us a different angle to look at. Yeah, we can do something like that. The second question that you asked me was, do you just look at the interactions, or do you also look at the content of what people are saying or writing, or pushing to others? And yes, we do that. So I didn't go into the details, but here they are. Essentially, when you have an edge, let's say this user making a comment on this post or writing this post, the edge has the timestamp and the associated feature vector, which the feature vector can encode the content of the post or the content of the comment. So that way we can incorporate the exact text that is being written between user and the content. And if you have users and you have users pushing content to others, so let's say this user forwards the message to this user and to this user, one can extend this temporal interaction network to have edges between users as well, making it more complex and more realistic. But we can do that as well, and we can update the model to quite simply to incorporate such analysis as well.
Thank you very much.
Hi, Srijan. So I have one more question.
Absolutely, go ahead.
Yeah, sorry. So it is little from the same Jodi model. So thing is, whether this particular model will work for static network also instead of dynamic. If I have, suppose, okay, I can give you some scenario. If I have a static network where instead of here link is timestamp, instead of that I have weighted link. So, and I also I need again ultimately I need the similar nodes. Maybe it is mainly the output is the classification of different nodes based on the similarity, similar behavior. So I need the same, but instead of dynamic network, I have a kind of static network with link is the weights. So whether this kind of framework will work, or is there any other model if you can suggest?
The static networks inherently don't have timestamps, right? Like that's the definition of static networks. Dynamic networks
that's what
have.
I'm saying.
So for static networks, don't use Jodi, use other static graph neural. So this is a graph neural network model, by the way. Jodi is a graph neural network model. So use static graph neural network models like GCN or Graph Sage, right? Like these are popular ones. You can find libraries on GitHub to do this directly.
GCN and the GCN
Graph Sage. I put the names on chat if you're interested.
Okay,
it's called GCN and Graph Sage, SAGE. So for dynamic, use Jodi, but for static, use GCN or Graph Sage.
Thank you. Thanks.
In fact, static network models were created first because they're simpler, and later, as research progresses, you go from static to dynamic.
Yeah, sure.
Cool. Yeah.
Thank you.
Good question.
Awesome. Thanks, Srijan. Once again, this was one of the most insightful and engaging conversations and sessions I have seen. I know it was a bit early for you, but thank you so very much once again for taking out time. We really, really appreciate it. Thanks a lot.
Yeah, thank you for having me.